Thank you.
So our next talk has an interesting title because it's reversing the process. We've seen the output. What did the input look like?
Okay. Thank you.
Try to turn the mic on. Just press the button. The handheld one.
Mm-hmm.
Hold the bottom, but it's right at the very bottom.
No, just press here.
Here. Okay.
Did it turn green?
Yes. Yeah. Can you hear me?
Yes.
Okay. Usually, people in many other professions don't talk about, I wouldn't say failures, but the work which did not work as expected. We scientists and engineers love to talk about our problems, maybe failures, and try to find some teachable lessons from them. This is a work which is still being done. It does not, our preliminary results, and I will say it from the beginning, were not what we expected, but I think we extracted some very interesting lessons from this. Okay, I think it's, okay, other way. So, let's start with this. What you can see here, this is Book of the Dead. This is papyrus from ancient Egypt. You probably don't know Egyptian enough to read this, but if you look at it, you see, okay, there is a 3-column typesetting, there is a text in black and with some words in red, and it's split into paragraphs, and each paragraph starts with ideogram. It's a bird, and it's a big ideogram, and you'll say, okay, probably it's each paragraph is a chapter, and probably the bird is as the name of this chapter, or maybe they are going to describe this bird, and maybe the red text is some important words there. Okay, next example. This is actually a book of Psalms. It's from about 1500. It's made in Krakow. It's very beautiful book with a lot of multicolored things, with a lot of interesting beginnings. But again, if you look at this, you will say, okay, I probably can split it into parts. Each part starts with a big letter. Some letters are red, some letters are black. Maybe they show me some subdivisions. And again, there are some red letters which are probably something, some important words, and so on. Of course, some of you might know Latin and might recognize the book of Psalms, and you will see that you have seen the beginning of Psalm and beginning of the verse on the Psalm. But even if you don't know Latin, you probably have some idea of the structure, right? Here's another thing. This is deck. And again, you might know tech or might not know tech, and you might know or might not know what's written here, but you can see that there are some paragraphs. Some start with bold text and bold numbered text, and you probably see that this is some subdivisions. And this is actually exercises in the book. And again, you might know, you might not know what's written here, but if you look at it, you immediately see the structure. So we have a thing that humans are very good in understanding visual cues. Humans are very good in looking in the page or several pages and say, here's the structure of my document. But there is an important caveat, if they can see them. And as we know from the first day of this conference, there are many people who don't see this, and we want to add with the cues instead of usual visual cues to make them to understand this. And we have spent a lot of time talking about tagged PDF project, and we know that the idea is to take the LaTeX text, add tagging, and create accessible result, accessible PDF, for example. The thing is that it's very easy to add Q to something like section, X, subsection, paragraph, or subparagraph. But what happens if you see something like this, like large BF series, or something like centering, or so on? What if you see a visual formatting? It would be very difficult to tag PDF project to understand what's going on and add the corresponding logical cues. And how important is this? Well, we looked at the arXiv papers. There are a couple of percent of arXiv papers which use visual formatting for section like headers, but much more for lower levels. Like if you have math, you have step 1, step 2, step 3, and you would want people to use something like enumerate or something like paragraph or subparagraph, but most authors just put some visual formatting there. So you would want to be able to recognize this. And our big motivation is related to another project you already heard about today, about arXiv reprocessing project, when they wanted to have most of the old papers, reprocess them to make it accessible. And again, our question was, what happens if you have only visual formatting? So we decided to create some system which will take visually formatted LaTeX text. And because we were thinking about arXiv reprocessing, we start from a source, not from PDF, extract logical information, and go on. Now, what is the biggest problem with machine learning? It's not the lack of resources. We have now much better resources. It's not the lack of algorithms. We have a lot. The biggest problem in machine learning is the lack of labeled data. You want a lot of data to teach your machines, and you want it to be labeled if you want machines to have the same understanding as you have. And it's very expensive and very difficult to make people to label. There is a trick, we invented it some time ago, which is this. If you have already structured data, you can make it unstructured, but it will be labeled because it's structured from the beginning. Okay? We did it with the BibTeX citation extraction project. We wanted to have a lot of labeled citations, and we just took structured BibTeX data, ran it through different BibTeX styles, and got a lot of textual information with different ways of formatting. And then we said, we asked machines to find out how to go back. Here we decided to do the same thing. We took a logically formatted papers from arXiv. I will talk about it in a second. We ran a special obfuscation script, which took a paper and randomly, but consistently within a paper. So basically, before I started the paper, I started to say, my sections will be large BF series, or my section will be just uppercase, or something like this. My subsection, and so on. It decided it randomly before starting to processing papers, and then processed some visually formatted papers, and this was our training set. And again, we were because we started with what we knew was correct logical formatting, we knew what should be back. So here is our pipeline. We took 120K papers from arXiv. We obfuscated all of them. We trained a model to restore it. And then we compared the results with what was from the beginning. We used BERT. It's the standard transformer model. And we used a couple of open source LLMs, which we tried to fine-tune with papers. Because we have labeled data, we could fine-tune them. What we used for evaluation, we used basically the difference between our ground truth, what we started from, and the results of this double process, obfuscate and go back to origin. And if we are absolutely right, our results should coincide with what we started. And we had a couple of measures. We have string distance between the result and ground truth, and so-called Zheng-Sasha distance, which is basically if you have a tree of sections, subsections, and so on, what is the difference between the ground truth tree and the tree you had? And the results were disastrous. Basically, what we got was completely different from what we wanted to have. And we have spent several months trying to do something with this, and we never were able to restore the structure as we wanted. So we are still working on it, we still have some ideas, but our preliminary result is that no, it doesn't work. It's something which you as a human are very good at doing, and machines, both transformers and the modern AI, seem to struggle with. So maybe we are not going to be substituted by cheap AI, at least soon. Okay, because we are scientists, our next question is why? What happens? Why people are so good at this and why machines are not so good? And here is our hypothesis. How do we do structure? And the idea is that when you think about structure, you first look at the document as a whole. You don't read it. You just glance through it and see, okay, it's what I have shown you in the documents. Let me get it back here. You see, you look at this, and by design, I made it not very, not big resolution. I don't think you can even read Knut's words unless you struggle with this. You see something as a whole. After you see something as a whole, then you start reading, but you already have some table which says, here is how my visual formatting corresponds to logical structure. But this is the part you do first. And if this is, and we actually have something to confirm this, because when we discussed this research with the reviewers, it was rejected from documents, but we still have some ideas of what to do. They showed us the paper, which actually was very good and at looking at logical structure. Unfortunately, we didn't do this from the beginning. And the way the paper did it, they started to read paper and started to build a tree. And whenever they found something different, they said, well, maybe this looks into, maybe it fits in the tree, maybe not. And the idea is that you already have local thing and you have global things. And you need to combine this. In our research, what we did, we put chunks into models paragraph by paragraph. And I think this is what actually made this not work, because you cannot understand the structure if you read it paragraph by paragraph. You need first to look as a whole. Suppose this is right. What can we conclude from this? First, we understand that humans decipher visual contents using change of the focus. But it has a very interesting implication for tagging and for accessibility project. Because one of the questions I have been asked when I talked to different people about tagging was this: why do you need so much effort? Cannot you just make screen reader tell people about visual formatting? So screen reader, instead of saying section introduction, would say boldface, large, introduction, and boldface, all and large, so on and so on and so forth. And now I understand why. And the reason is that when you process your information linearly, like you do with screen reader, instead of being able to look it visually, you cannot actually easily understand the structure. So I think the decision of standards committee, PDF standards committee, to put logical structure rather than visual structure for accessibility was right decision. I don't know whether they had experiments working with this or just had understanding of working with blind people, but it was a really good decision. Now I understand why. And the other thing, that if you want to do logical deciphering of the logical structure, you need to do some focus change and some attention change, and you need to be a little bit more sophisticated than just putting your text into AI paragraph by paragraph and telling AI to find out some structure in it. So that's what our work was about, and I'm happy to answer questions about it.
So do we have questions? Yes, I see a question back there, and then we'll go to Norbert for his question.
Hi, my name is Charles Stats. I was just wondering, did you try doing something like this with sort of a modern, one of the very recent models that has tools added to it so that it could, read a substantial portion of the document, and then has a tool that lets it go back and reread particular portions that it might find especially interesting, because that's sort of standard now.
Yeah, when we start, we did not. We used thank you. When we started last year, we did not have this, and we did not. But it's very interesting. Yeah, that's what we are going to think about. But we worked with standard at that moment Llama, open source Llama models. But thank you. It's very good question. Very good suggestion.
Yeah, Norbert Reining here. Did you check with AI? AI did something very similar, like, I don't know, 8 years ago. They have drifted away a bit, but they have done exactly like this, trying to get the structure out of an image of a PDF with a blob. Might be interesting to see what they have done. I think this is still available in some way. That's the one question, as a comment just. The other, you said we, the authors, in which setting did you do this research? I was interested in.
Okay. Thank you. Thank you for the comment. It's great. It's a great hint. I will look into it. About setting. UMass has a very interesting program which is called Industry Mentorship. What they do, they take a postdoc, they take a group of postdoc or graduate student, they take a group of students, and they find people with interesting problems outside of UMass, and for certain credits they try to solve this problem. And it was second time I worked with UMass on this. So basically my co-authors are from UMass. They are beginning researchers, and one of the things I wanted to say is that they're absolutely great. In both my bouts working with them, I was really surprised and impressed by them. But this is a great program, and I hope that other universities would do this because it's a very interesting thing to take some real life problem and ask your students as your projects to do this.
The initiative was from the Zuckerberg Foundation.
Excuse me?
The initiative started from the Zuckerberg Foundation?
No, yes. Well, yes and no. I worked at Chan Zuckerberg, and they contacted me at CZI, but it was more personally that it was not sponsored by CZI, and the sponsor of computer time and everything was UMass.
Sponsor arXiv, please.
CZI sponsored arXiv a lot, and I think that
Besides Google, none of the big players dedicates a single cent to arXiv, just to mention this.
Hello, Matthew Scala here again. Further to the question about using tools to reference earlier in the document, I hope that something else you'll try will be just using your existing approach with a model that has a larger window.
Yes.
Because today we have even very small models that have very large
Yeah.
windows, and I think that could well be enough to make it work a lot better.
Yep. Absolutely. Absolutely. I think that our biggest mistake was to take paragraph like chunking in the beginning. I think we have had resources to do it larger, and we should do it. And if you see a research where you did not make any mistake, show me.
We'll have time for one more question, and we'll have Norbert up here.
Yeah, Charles, that's again, one more question I wanted to ask. How carefully did you clean the data to make sure that you weren't including documents that, for instance, had inconsistent usage of the sectioning, so that maybe they either didn't, your training data might have started with documents that either didn't use sectioning commands or sometimes use bold instead of sectioning, which would have made it very difficult for the model to learn anything.
Yeah, it's very simple. I must confess that we did very simple criterion. We ran obfuscation script, and if obfuscation script didn't change anything, we assume that the paper doesn't have sections, subsections, so on. But the thing that somebody used both visual and logical formatting on the same level never came to us, and you are the first who says this, but knowing some authors, yes, this is possible. This is possible. Authors are evil people. Thank you.
Okay, thank you very much, Boris.